Hello guys, in my last video I posted this question and asked for your opinion or answer in the comment section, and I promised that in my next video at 11 a.m. today I am going to provide an answer to this question and explain why I have picked my answer. Anyways, let us look at the question for those who are seeing the video for the first time. It says, a stone and a piece of paper were dropped from the same height at the same time in a vacuum devoid of external forces or interference. Which of them will hit the ground first? And my response was both will hit the ground at the same time. Now in this video I want to explain why both of them will hit the ground at the same time. If you've watched this video to this extent, thank you very much, but I want to let you know that I will try to explain this in the simplest way possible without using complex calculations or equations. I'll try to explain this from a layman's point of view so that everyone can be carried along and everyone can understand, irrespective of your discipline, be it sciences, arts, engineering, commercial, everyone can understand. So stay tuned. Now, let us take note of this underlined word because the condition under which this would hold is that the event happened in a vacuum devoid of external forces or interference. What it means is that there is no air resistance, there is no pressure, it is a pure vacuum and no external interference. Having said that, let's dive right into it. So this is an image demonstrating what we are trying to explain. A stone and a paper on this level or at this level are released at the same time and both were allowed to fall to the ground. This is the ground level. So we understand that everything that is an object that is released from a height will be acted upon by gravitational force. We say that anything that is thrown up will fall back under the influence of gravity. And in physics, that gravitational pull has an acceleration that is called acceleration due to gravity, g, and it has a constant value of approximately 10 meters per second square. This is a constant value and it is regarded as the acceleration due to gravity for which objects fall from height. Before we go right into the video or go further into the video, we're going to explain what this 10 meters per second square, this constant g of 10 meters per second square means. When we say acceleration due to gravity is a constant value of 10 meters per second square, it means that for every 1 second, the velocity of the object changes by 10 meters per second. So we're going to look at the stone in the first instance and see what is happening regarding g being 10 meters per second square. While the stone is here, it is not moving. It is 0 meter per second square. So the speed of the stone at this point is 0. When it is released, after 1 second, the speed will increase from 0 to 10 meters per second. That is what this implies. After another 1 second, it will increase again by 10. And after another 1 second, it increases again by 10. So you see that the speed will keep increasing after 1 second to 10, and then 20, 30, 40 in that order until it hits the ground. So again, after 1 second, the speed would have increased to 20, obeying the gravitational pull. And after another 1 second, the speed would have increased to 30 meters per second. So if this is the ground level, the stone would hit the ground at a velocity of 30 meters per second after a total time of 1 plus 1 plus 1, 3 seconds. So the takeaway point here is that this explanation is devoid of how heavy the stone is, the weight of the stone, or the mass of the stone. It means that the gravitational pull does not consider the weight of the stone. So similarly, we can apply this to the paper. It means the weight of the paper is not to be considered, and the same thing will happen. And it will also take 1 plus 1 plus 1, which is a total of 3 seconds for the paper to fall to the ground. So, from the foregoing, it is evident that the acceleration of free-falling bodies is independent of their masses. Therefore, we can say that the stone and the paper will hit the ground at the same time. I hope this video was helpful and you enjoyed it. Thank you very much for watching.